Okay, now this is the third method known as the method of substitution. The concept is easy because it's same as one of the shortest method. And then we're having equation, of course, to say resolve x squared all over x negative 2, of course, x negative 3x squared into partial fractions. This is very important, and of course, I lay emphasis on which type of partial fraction is this so we can have an overview of that type of partial fraction. Of course, I say the partial fraction is based on how the denominator looks like, right? And then you must also know, it's very important, I didn't say that in the beginning of our class, you must know that you can't solve a partial fraction if the degree in the numerator is higher than the degree in the denominator. For example, now you cannot solve a question where you're having x over let's say we're having x squared plus 1 and you're having x plus 2. The degree in the denominator must be higher than the degree in the numerator. So if you're given a case that should resolve this into partial fraction, you must first of all do your long division. You must first of all do your long division. Of course, you're going to solve questions that are going to be very similar to this. For this is not what we're here to do today. So now of course, our point is what? We are having a denominator looking as x negative 2. So let me write it out for clarity purpose. We are having x squared over what? X negative 2, x negative 3 squared. So you're saying something like this, of course, is more like x squared over what? X negative 2, x negative 3, and x negative 3. This is something like this, right? How would you get your expression for in terms of a, b, and c? How will you go about it? Now, it's very peculiar. For this type of partial fraction is called repeated linear factors. Now, it is very similar that in this case, one of the factors is repeating twice. Now, let me show you how your general solution, how you place your a and b will look like. Of course, it's very wrong for you to go by this assumption. Please don't approach it using this method. Do not, please. Now, approach it using this method. We're having, of course, we are seeing there are three factors here, right? Even though one is square, we're seeing three factors. Since it's called repeated linear factor, we're going to write it like this. For the first factor, which is going to be a over what? X negative 2, right? This is correct. Plus b. Now, you are seeing the first factor, which is x negative 3. This is the first factor. But there are three factors here because of having x negative 2, x negative 3, x negative 3. That's what it means. In not sure that's what it means, right? But we're going to have plus c over what? X negative 3 all square. That's to say, anywhere you see a repeated. Now, let me show you something. Imagine we are given a question that is just x squared over x negative 3 square. This is the same approach I'm going to do. I'm just going to not consider this. I'm just going to have a over x negative 3 for the first one, then b over what? X negative 3 or square. Please, it's very important you take note. It's very important. If you're having a case, this is a repeated linear factor. But in this case, this is a repeated linear factor, but you're still giving another factor. So please, that's what's the concept. You should understand this. So I'm using this principle as this. Because if I'm giving an extra factor, that factor fails, then we still have what we have here. So that's the concept. Now it's very important we take the LCM. I've always laid emphasis on LCM. The LCM between all these three is what we have here, right? So we're going to take LCM. We forgot to put our third quality sign. So we are having, of course, x squared over what? X negative 2, x negative 3 squared. Of course, taking LCM, we are having assuming. Now it's very important you must see, listen, please listen. I showed you a concept that for us to take the LCM, in that last video with this concept. In this case, we're having the LCM here as what, x negative 2, x negative 3 all squared, right? Multiply, take each of these term and multiply by the LCM. You will have the more of like the taking LCM of all these things. It will be the expression. Let's take for a now. Let's take for a. We're having a over what, x negative 2 multiply by LCM, which is x negative 2 x negative 3 square. This will cancel this. You have a bracket x negative 3 square. Do this for all the terms. Do this for all the terms. So let's take now. So we have, of course, we have for the first one, this becomes a bracket x negative 3. For a now, for us to get this, take the LCM between all these things and use it to multiply this. This will cancel this. That's what we did here, right? That's what you do for all the cases of what, these individual fractions. So we have plus what, b. Of course, you're saying that x negative 3 square is one of these. So this will cancel one of these. If this, the LCM, see, we have b bracket what, x negative 3. If you multiply by the LCM, which is x negative 2, x negative 3 all square, one of these will go with one of these. So you're just left with what, b bracket x negative 2 bracket x negative 3. Now for the third one, plus c. Of course, you're seeing that the LCM in terms of c is majority, is c has majority of the LCM. So you can just see, if you multiply c over x negative 3 all square multiplied by the LCM, which is x negative 2 and x negative 3 all square, this will cancel this. So you're just left with only these two. So you have cx negative 2. So this is the concept. So all over what, x negative 2 bracket x negative 3 whole square. Of course, the concept is easy. We have seen a case where the two denominators are what, equal. So you cancel them out. So you're just left with what, x square is what, assumed to be equal to what, all these, you have a bracket what, x negative 3 squared plus what, b bracket x negative 2 x negative 3 plus c x negative 2. Now it's very peculiar you understand this step. This step is very important because of that's what boils down to the new method of substitution. Now you must note that what type of fraction is this? This is called repeated linear factors. Repeated linear factor. Of course, that's the type of partial fraction. You must note some of these steps. This is one of the type of fraction. The first, when we talked about the cover-up method, we talked about linear factors. The second, which is a method of coefficient, equating the coefficient, we looked at factorizable linear factors, factorizable factors, and then now, of course, we're talking about the method of substitution. We're talking on what, the repeated linear factors. Of course, now it's very important. Now, the method of substitution is very important because of it's easy for us to assume which value we substitute our value for x. If we take x as 0, we cannot calculate. Of course, one of the reasons why we're substituting the value of x is to make a, b, and c subject formula, right? So please, if we make x equals to 3 here, a will be 0, B will be 0, and we'll have the value of C. So first of all, we're going to take what? We're going to say let x be equal to what? 3. So if we make x equal to 3, we have what? Bracket 3 square is equal to what? A, of course, 3 negative 3, this will be 0. The square of 0 is 0. So you can see that A will go out, plus what? B bracket what? This will be 3 negative 2, which is 1. So we have 1 bracket. Of course, this will render the equation 0 because 3 negative 3 is 0. Plus what? C bracket 3 negative 2 will have 1. So therefore, you see that we have the square of 3 is what? 9 is equal to what? Of course, this is 0 plus 0 plus C. So therefore, you see that C is equal to what? 9. So therefore, C is equal to 9. That is one of the power of this substitution. So now we have successfully made C Schaeffler formula and C is equal to 9. We're going to look closely. If we look here in one of these, we see that if we make x equals to 2, the value of B will be 0 and the value of C will be 0, right? So we're going to make x equals to what? 2, so that we can successfully eliminate this and also eliminate this, and we're going to have our value for A. So we're going to say let x be equals to what? 2. So if we do that, we have 2 square is equal to what? A. So A as what? 2 negative 3 square plus B bracket. Of course, 2 will render this, 2 negative 2 will render this 0, and render this negative 1, plus of course this will be what? C will render this, of course C will be rendered 0 because 2 negative 2 is 0. So we have the square root of 2 as 4 equals to what? A bracket negative 1 square plus 0 plus 0. So therefore we see that A is equal to what? Because the square of negative 1 is 1. Make A Schaeffler formula. A is equal to what? 4. So that's the concept. Now see, it's very important that we have a value of A, but we have a value of C as 9, and we have a value of A as 4. But now, how do we find the value of B? How do we find the value of B? Now the concept is easy. For us to look for B, we're going to assume that let x be equals to 0. And since x is equals to 0, we're going to now substitute the value of A and C into this equation. Now, this equation is very important. Of course, all of our assumptions are coming from here. So please, we're going to assume that. So we're going to say let x be equals to 0, C equals to 9, and A equals to what? 4. So we do that, we're having 0 square is 0 is equal to what? A has 4, so we have 4 brackets. Of course, negative, we have 0 negative 3 square bracket, of course there's no bracket, plus B bracket 0 negative 2 bracket 0 negative 3 plus C. Of course C is 9, we have 9 bracket 0 negative 2. So we're going to work with all this. We have that this is 0 is equals to 4 bracket negative 3 squared plus B negative 2 negative 3 plus 9 into what? Negative 2. That 0 is equal to what? 4. Of course, this will be what? 9. This will be 9 plus B. Of course, negative 2 negative 3 is 6 plus what? This will be 9 into what? Negative 2. So we have, of course, we're going to make this real formula, which is 0. Let's work with this. So 4 times 9 is what? 36 plus 6b negative what? 9 times 2. 9 times negative 2 is 8, negative 18. So we have 0 is equals to what? 36 negative 18 plus 6b. Of course, this will be equals to what? 36 negative 18 is what? Negative 18, sorry, 18 plus 6b equal to 0. So we're going to make this Schottler formula. So we have 6b is equals to negative 18. Divide both sides by 6. So we have b is equals to what? 16, negative 16 over 8. This will go into this 1, this will go into this 3. So b is equals to negative 3. So therefore we have the value of a, b, and c. A is 4, c is 9, and b is negative 3. So I'm going to substitute the values into this. So let's wipe this off. Square over what? X negative 2, x negative 3 all squared is equal to what? A. We have a as negative a. We have a as what? 4, right? So we have 4 over what? X negative 2. We have b as negative 3. So we have negative 3 bracket x negative 3. Then we have plus c. C is 9. So we have 9 over what? X negative 3 all squared. Now we can decide to factorize. So let's factorize this. Of course, we have 4 over x negative 2. So let's leave that. So we have the next one. We have plus 3 is common. X negative 3 is also common. So we have 3 over what? X negative 3. Of course, factorizing this out. Let's bring this first because we are working with positive before negative. We'll be left with also another 3 over what? X negative 3. Then we have negative 1. Because of everything that is here is what we have brought out. So please, this is equal to what? X squared over x negative 2 and x negative 3 all squared. So this, please, this is the concept of what? Method of substitution. Concept is very easy to understand. So the concept is easy, more of like taking everything step by step and working everything out. So see you.